All right. Algebra 1 folks, thank you for hopping in today, joining us on Lesson 3. This is following Lesson 2 and one step before Lesson 4. So what we saw in Lesson 2 was some solving equations that should look familiar, some middle school skills coming back to you. It was a nice little refresher coming off of our statistics unit. And some skills that are needed as far as advancing into this Algebra 1 course. So today, in this lesson, it's really kind of a matter of putting sense to these equations, not just, hey, here's an equation, can you solve it, can you find your solution, and can we move on? But how can we make sense of these equations and how they work in some kind of real-world application? So how can they help us in a possible situation that we might be faced with, that we would need to have those skills as far as setting up the equation and solving the equation, finding the solution, and then making sense of it. So that's really the topic for today. It's equation application. I have this titled. It's really just how do I apply these in real life situations. So that's kind of leads us right into our first blank here. It says, now that we can solve equations, what are they good for? Equations are used for a wide variety of ways in the real world. Okay. You're going to notice a handful of problems below that you might be presented with in real life. And there's oftentimes, too, where you're solving problems in real life and it involves an equation that you've made or used or manipulated, and you didn't even really associate it with algebra or math or equations. You were just kind of doing it because it just feels natural. A lot of what we do in our day-to-day lives that involve numbers is equation-based. So you're going to see some examples today below, and it'll really just make sense of how is what we're doing related to the real world. We're not just giving you an equation and saying solve it because I want you to solve it, but it's really useful in many, many applications. So we're going to look at a couple different types of applications. One of the main types of applications involves geometric shapes. Okay, and because of that, it's really nice to be reminded of the following formula. So it's probably been a while since you've seen these. I'm guessing at least 6 months, because in our last unit we didn't talk about these, and it might have been around 6 months since you really had a normal version of school. So here we go. So a couple formulas for squares that we need to know I have pointed out over here. We have P equals 4S, which is just standing for the perimeter equals your 4 times the length of your side. And then we have A equals S squared, which just means the area of this square is going to be your side squared, or a side times a side. So again, we know that all 4 of these would be the same. So your perimeter would just be, again, 4 times each one of those sides. And then, like it says over there, your area is going to be a side times a side, or side squared. For a rectangle, a little bit different because not all 4 sides are the same. We get the perimeter is 2 times your length plus 2 times your width. And for the area, we get length times width. Again, very similar to the square, but since we don't have identical side lengths, we just multiply the width times the length, and it gives us the area there. So let's go ahead and dive right into one of our examples here and take a look and see how equations can be built and then used to find our solution. Here we go. So it says in example 1, the length of a rectangle is 5 feet more than the width. The perimeter of the rectangle is 30 feet. What are the dimensions of the rectangle? So right off the bat, a couple good things that I highly recommend before we get into maybe designing this equation is just simply drawing it, right? What do we know? What do we see? So no judging my not perfect rectangle here. That's about as good as I can do on my Chromebook here. And then we're going to start filling some things in that we know. It says the length of the rectangle is 5 more than the width, okay? So we know that we don't know the width, right? It's just the width. Let's use W for width. And we know that the length is 5 more than the width, right? So I know that the length, which is this other side here, is 5 more than the width. Well, we know that this is the width, and we know that this one is 5 more than the width. So let's just call this the width, and this is the width plus 5, right? Easy enough. Okay, so that's what we know so far. What else do we know? We know the perimeter is 30 feet. Based on this up above, we're going to be using this formula, right? Perimeter equals 2L plus 2W. But we just simply know that the width is 5 more, or the length is 5 more than the width. So we're going to go ahead and say, well, we know the perimeter is 30, so we know that our formula is going to equal 30. And we know that that involves 2 widths, right? So there's 2 times our width. And we have 2 times our width plus 5. So we also have and an additional 2 times our width plus 5. Okay, so let's go ahead and just kind of let this play out like we're solving an equation. So I know that this is 2w here. 2 times w is just 2w. Over here we have this distributive property. So we have 2 times w, which is, again, 2w. And we have 2 times 5, which is 10, a positive 10, equals 30. I'm going to go ahead and look to combine like terms. So I see that this 2w plus 2w is 4w. And I know that that still is equal to 30. Now I'm going to look to isolate this w. How do I get this by itself? Well, I need to do the inverse of a positive 10, which is minus 10 on both sides. I know 10 minus 10 is 0, so I'm going to leave this part below blank. I have 4w equals 30 minus 10 is 20. And then my last step is to figure out what is this 4 times what number is 20? Well, I can do the inverse to figure that out, and I get w equals 5. So that helps us greatly, right? So I can go ahead and go back and say, well, I know that the width is 5, so it's telling me w is 5. So it's telling me anytime over here in this picture that I see a w, the w is representative of 5. So tell me if this makes sense, right? So I know that now, well, this side and this side are the same, and I know that w is 5, so it's saying this is 5 and this is 5. And we know that this side, this length, is 5 more than the width, so we're saying, well, this is 5, but it's 5 plus 5, that's 10. And that means that since these sides are equal, that this is 10. And we know the perimeter is 30. So do these add up, right? We have 10 plus 10, 30, 20, plus 5, which is 25, plus 5, which is 30. So we can go ahead and say, when it asks, because I need to make sure I'm answering the question, it says, if the perimeter is 30, what are the dimensions of the rectangle? I know that the width is 5, and then the length is 10. Simply did that by just drawing, letting ourselves visually see what's happening, and then using one of those formulas provided. They won't always be provided for you. That's really just a couple basic formulas you should know. It was nice to remind you, but yeah, went ahead and just used those couple of givens to figure out what the length and the width were. We're going to go ahead and move that into example number 2. Here we go. Looks like it's another one about a rectangle. I see that word here just a few words into this first example. Example number 2. The length of a rectangle is 3 less than 2 times the width. Pretty important, is 3 less than 2 times the width. If the perimeter is 18, what are the dimensions of the rectangle? Okay, well, it'd be nice if we had a rectangle, so let's create it. Here's our created rectangle. We're going to go ahead and call this the width, and we'll call this the length. Okay, so what can I do? The length of the rectangle is 3 less than 2 times the width. Okay, so let's go ahead and keep this. It's giving us some information about the length. So I'm going to switch this from length. We know that it is 3 less than 2 times the width. So it's 2 times the width. So we know that it is 2 times the width, but it's 3 less than that. And less than is subtraction, right? It is 3 less than 2 times the width. So 2 times the width minus 3 is what we're given right there. And I'm going to get rid of these so it's a little bit cleaner. And what do we know? It says that the perimeter is 18 feet, right? So we're going to use a similar formula. It wants to know what the dimensions of the rectangle are. It's giving us the perimeter, so we're going to use the perimeter formula, which is 2w times, plus, we have 2 times 2w minus 3, right? Because we have 2 of those, right? We have this one and this one, equals 18, right? And then we have some math to do here. We have the distributive property happening. 2 times 2w is 4w. 2 times negative 3 is negative 6. I can bring this 2w down. There's an addition. We have 18 over here. I can combine like terms between 2w and 4w, which gives me 6w. I bring this minus 6 down, equals 18. I need to start isolating w. So to get rid of this minus 6, the inverse of subtraction is addition. I'm going to add 6 to both sides. Negative 6 and 6 cancel out the 0, so I'm left with 6w equals 18 plus 6 is 24. I'm going to go ahead and divide by 6 on both sides, and I'm going to get that w equals 4. Okay, so all we know right now is w equals 4. So anywhere over here that I see w, I can plug a 4 in. So simply I know that this right here just is 4, okay? And then right here I can plug it in. This says 2 times w, so this is going to say 2 times 4 minus 3, right? So it's going to say 2 times 4 minus 3. Well, 2 times 4 is 8. 8 minus 3 is 5. So this is saying that the length and the width should be 5. Let's use red here. It should be 5. and 4, right? And we know that the perimeter is 18, so let's check our math, right? If this side's 5, we know that, this side must be 5, and this side must be 4. Well, 5 plus 5 is 10, plus 4 is 14, plus 4 is 18. So we can say something like the width is 4 and the length is 5, and it matches up with the information that was given. Very nice. All right. Moving on. An example that does not involve a rectangle. We have a triangle here, right? It says the second angle in the triangle is 4 times the first, and the third angle is 30 less than the first. Find the measure of each angle. So something we need to know is that all triangles, no matter how they look, if they are isosceles, if they are scalene, if they are equilateral, all triangles add up to 180 degrees. So it's a good thing to know that just this triangle in general equals 180 degrees. Okay, and we're being told about each one of these angles. We know that the second angle of the triangle is 4 times the first, and the third angle is 30 less than the first. So, okay, we don't know anything about the first, so let's just go ahead and call it x, right? Our first angle plus our second angle, which is 4 times the first. So we're going to have 4 times our first angle plus, well, our third angle is 30 less than the first, so we can have another x minus 30, right? We have angle number 1 plus angle number 2, which is 4 times as big, plus angle number 3, which is 30 less than the first one, is equal to a total of 180 degrees. And I'm going to go ahead and clear these up. So I can just go ahead and start. Well, you already noticed, I'm sure, that we have some like terms to combine. I have 1x plus 4x plus another 1x, which makes 6x minus 30 equals 180. So now I can start to isolate this x. The inverse of subtracting 30 is adding 30, So I'm going to add 30 to both sides. I'm going to get 6x equals 210. And then I'm going to take that information and I'm going to go ahead and divide by 6. So then I can take divided by 6, divided by 6. I'm going to go ahead and check my math and make sure that 210 divided by 6 is a nice number for us, and it is, and it's x equals 35. Well, that's great. So what does that tell us? I know that every time up here there's an x, it's representative of 35 degrees. So really, we're calling this one x, this one 4x, and we call this one x minus 30. So let's plug 35 in for every x. So that means that in this kind of matching triangle, well, x, that's just 35. 4 times 35, this one right here, would be 140. And this one is x minus 30, so that's 35 minus 30, which is 5. Can I add these up to make sure? 140 plus 5 is 145, plus 35 is 180. So we can just say maybe angle 1, angle 2, and angle 3. We can call them 35. We can say it equals 140, and we can say this one equals 5. Okay, last but not least, okay, we have an example here of a consecutive numbers problem. So it says the sum of 3 consecutive integers is 63. Find the integers. So we know that 3 numbers, the sum, the addition of 3 numbers in a row, so 3 consecutive, it means they're in a row, is 63. Find the integers. So this is all we know so far. Is that a number, some number, plus that number plus 1, because they're in a row, right? Plus that same number plus 2 equals 63, right? And I'm going to explain this. Here's a number. Here's 1 bigger than that number. And here is 2 bigger than that number, right? 3 consecutive integers. Think about this, right? 3 consecutive numbers are 5, 6, and 7. Well, how does that look? 5 plus 1 plus 5 plus 2, right? 5 is here. 6 is 5 plus 1. I'm adding 1 to my first number. And 7 is 5 plus 2. I'm adding 2 to my second number, right? So I have my first number. I have my first number 1 bigger. And I have my first number 2 bigger. And I know it equals to 63. So I'm going to get rid of these to clean this up just a little bit. And we're going to go ahead and start simplifying this so I can figure out what those 3 numbers are, right? You could even guess and check here, right? I mean, just simply, I don't know the answer to this. 63, I'm going to guess the numbers are right around 20. Right? Because 63 divided by 3 is right around 20. So I'm guessing first, right? I'm going to say, well, 20 plus 21 plus 22. I think that's it. So this math should go ahead and check out to that. 20 plus 21 is 41, plus 22 is 63. So that looks like it's our 3 numbers. let's go ahead and make sure mathematically, right? Because if we get a huge number here that's not 63, if the problem gives us 1,055, we don't want to have to guess and check. We just want to be able to use this math to do it. So can I combine like terms? I can. There's 1, 2, 3 x's, right? 1, 2, 3. They're all positive. So that's 3x plus, I have a 1 and a 2. They're both positive. So plus 3 equals 63. Well, I can subtract 3 on both sides. And I get 3x equals 63 minus 3 is 60 divided by 3. And I get that x equals 20. So I know that every time there's an x, it's representative of 20. So this is really saying, here in blue, this is 20 plus 1 plus 20 plus 2, right? Well, I knew that each number was going to be one more than the next because it said 3 consecutive. So I know that my numbers must be 20, 21, and 22 are my 3 consecutive numbers. Okay. Consecutive numbers are a pretty popular problem you'll see on tests or even practices or just application of equations. So you got a chance to see some different geometric shape problems as well as consecutive integers problems. Just kind of a little dip into some of the things that we see when we're asked to solve equations. So I appreciate you following along. That is all we have for lesson 3. Feel free to hop into your traditional practice or error analysis and put these skills to use. I appreciate you following along.